Okay, so this is a stoichiometry problem, and just a typical problem, but it has a lot of steps in it. So that's why I want to demonstrate how it's done, so that you guys can do similar problems on your own. So we're gonna have to be putting together kind of everything that we've learned before. So the one thing that we don't have to do that's already done here is balance, okay? Because if you see, everything is already balanced, right? So we can skip that step, but the first thing to take a look at is from this balanced equation, you know that 2 moles of potassium yield 1 mole of hydrogen. Okay, we get that from the 2 moles of potassium here and the 1 mole of hydrogen here. Because there's no number there, we assume it's just 1 mole, right? Okay, so we want to figure out, though, how much hydrogen is used, right? And we want that in grams. So uh, we want to know how much is used if we only use 0.04 moles of potassium. So the given here is 0.0400 moles of potassium. Okay, so we can write out our given, and it is 0.0400 moles of potassium. Okay. The unknown number is the moles of hydrogen. So because the given substance is in moles and the unknown substance to be determined is also in moles, this problem involves a mole-to-mole conversion, which we've done before. So to solve the problem, you need to know how the unknown moles of hydrogen are related to the known moles of potassium. So you guys already learned how to derive mole ratios from the balanced chemical equation. So the whole thing that I just had you do before in the last lesson of finding the ratios, this is why, okay? Because we're going to have to use that. So, mole ratios are used as conversion factors to convert the known number of moles of one substance to the unknown number of moles of another substance in the same reaction. So, this is kind of the formula. We go moles of known e uh, times moles of unknown over moles of known. And this should make sense in a second, and that will give us moles of unknown, right? Because if you look, moles of known cancels out, and we're just left with moles of unknown. Okay, so now we just fill in what we know. Okay, so 0.0400 moles of potassium. That was our given, right? Our moles of known over, or times 1 mole of H2 over 2 moles of K. So as you can see here, this is our molar ratio, right? So if it's just one of the examples that you would have done before if we were looking at the ratios. So we can see that we already saw that 1 mole here, and that 2 moles here. So you need 2 moles of potassium in order to yield that 1 mole of hydrogen gas in this reaction. So that's why we can use this as a conversion factor. Okay, so that was the reason why we did that whole lesson last time on molar ratios. Okay, because now, as long as you can find what the molar ratios are, you can do these problems pretty easily and pretty quickly. Because now all we do, this, is we solve this, right? Because, as you can see, moles of K cancel out, and now we just solve. So 0.04 times 1, it's still 0.04, divided by 2, okay? And that gives us 0.0200 moles of H2, okay? And if we wanted to go a step further and figure out how many grams of hydrogen gas were produced, then we would just set it up as this. Right, we would convert the moles to grams. So 0.0200 moles of H2. 1 mole of H2 equals the molar mass of H2. And H from the periodic table equals 1. And we have 2 atoms of H, multiplied by 2, and we get 2. Okay, 2 grams per mole. So we put that 2 here, and then we just do this out, right? So we would get 0.0400 grams of H2. All right, and it's that simple. And that's all we are going to take a look at right now, because the problems that we're going to be looking at going forward are really just going to be doing conversions just like this.